operates. Well, so when that happens, it's frustrating when we're sitting here watching that and we get that sort of thing happening during a presentation, or maybe it's during your email or during a web page you're trying to load. But when it happens to a business where their data is not being served fast enough, or maybe not at all, that is what we call the app data gap. And it's extremely frustrating for a business. It's worse than frustrating. It can be revenue impacting. In most cases nowadays, it probably is revenue impacting. If that happens to someone like an Uber or Lyft, you can imagine the revenue impacts when their data is not being served. So what happens? What does that IT department get faced with when they are faced with that sort of a situation? So it's reacting to unexpected problems. So they're working maybe late at night to try and recover that from that condition. Maybe they're working weekends. Whatever it is, it's very frustrating. It's very time consuming. And what they tend to be doing is looking at, maybe they have a Splunk on premise or some other monitoring tools, and they're starting to dig through all of those logs, all of those metrics that they have collected on premise, and start trying to correlate things, understand what's gone on in their environment. The problem nowadays, these environments are so complex that no humans can really grok what's going on. And so they have these tools, but there's still a lot of correlations that you have to do manually and really digging into root cause. They're not figuring out root cause for you. That's still the humans that is faced with that. So what they tend to do at that point, those IT admins, is to call their vendors and ask for support and get help. And so when that happens, they get frustrated in another manner. Typically with traditional support models, what's going on is you call, you get level 1, you answer a few questions, they maybe ask you to try something and send you more information that they can try and help you with. When that doesn't work out, they escalate up to level 2. You go through typically the same kind of process back and forth of trying things, getting more data. Maybe they even are asking you to recreate the problem. So here you have an outage that's caused your data services to not either be fast enough or available at all, and they're asking you to wait till it happens again and hopefully have enough information that time to solve the problem. So obviously it's a lot of high stress, wasted effort and time, and very business impacting. So if you take a look at the transportation industry, it's not unlike that. So when that happens to you in the car when you're driving to work, you get frustrated. You've probably all been in, at least behind somebody who's been in an accident. And that is very unsettling and very time consuming and frustrating again. But that's changed, or is being changed. So the future with transportation is self-driving cars. Okay? And how do they do that? Well, there's 3 main components that allow the self-driving car to become a reality. Number 1, it's rich telemetry. There's dozens of sensors that are on those cars, cameras, radar, so on and so forth, collecting data literally every millisecond, some number of milliseconds. That information is getting sent back to someone like Tesla, to their engineers in the cloud, to understand exactly what's happening on all of these cars and understand how they can build their algorithms better to make driving safer, so on and so forth, through machine learning and such. Now the problem here is that if all you got to learn from in that model is how you were driving, and the only thing that ever taught your car how to drive was your driving ability, it would never be any better than you are. It would never know all of the different circumstances that occur over hundreds of thousands of cars and millions of miles of driving. And that's why it's important in that kind of scenario to have global learning. So, if you can do it for the transportation industry, why can't you do it for infrastructure? And that's what we're attempting to do at Nimble with InfoSight. So InfoSight collects cross-stack telemetry. So what we mean by that is every array, all the way up through the virtual environment, sends information back home in the form of sensors to us so that we understand exactly what's happening every second of that infrastructure's life. That all comes back to Nimble storage in the cloud, where we can perform cloud-based predictive analytics so that we can take a look at all of the systems around the world and see how all of them are behaving. We, in fact, collect about 1 million pieces of information every hour from every array in the world in the install base. All of that gets back to our cloud-based predictive analytics platform, which is part of InfoSight.
Just to clarify, you said the whole stack, but then it sounds like we're talking about storage. So are we talking about collecting?
Storage all the way up through the virtual environment, up to VMs as well.
Okay. So
not inside the app, but
anything storage related all the way up through the stack. Yeah.
That's right. So we understand how the virtual CPUs are behaving, memory in there, all the way down that data path to the data stores, VMDKs, down to storage, across the network.
And the purpose of this is storage performance tracking. That's really what you're
The real purpose of this is helping with that app data gap, eliminating that through understanding what's going on in that entire data path. Okay? Because it turns out that about 54% of all of the issues we deal with at Nimble Storage Support have nothing at all to do with storage.
It's always the network.
Something like the network, the configuration. We always get blamed. Storage gets blamed almost all the time. It's not always that. Most of the time it's not. Okay? So that's why it's extremely important to have the cross-stack telemetry. It's important to get it into the cloud so we can see what's happening, so our data scientists can learn from it and apply the machine learning algorithms that we need. And again, it's very important that we do global learning for exactly the same reason. It doesn't help anybody if everybody's car drives how you drive. It needs to drive the best of everybody. And that's what we're attempting to do with this global learning. Understanding what's happening across tens of thousands of arrays and where they may be seeing issues that might cause an app data gap and how to prevent those from happening anywhere else in anybody's infrastructure.
So as a customer, how am I benefiting from your global learning of everybody else? Because obviously my performance issues are local to me. What's the big picture with everybody else?
I mean, it's simple. I'll get to some examples, but simple examples. Let's say we know that a customer that has this kind of performance workload and has this particular issue happen to it, and we can do a query across the entire install base to see who else is susceptible to that, and we can protect you from hitting that same issue. That's exactly what we do every day.
So just go back to what Ethan was asking as well. You're gathering information, obviously, from the storage appliance. Are you then pulling data from vCenter?
That's right.
VM stuff?
That's right. We're the storage appliance. Think of it as more of a data collector that happens to serve storage, but it's collecting data from the storage array all the way up through the virtual environment using the vCenter APIs to do that. So it's a big collector of data. It happens to be running storage. Okay. So what does this all mean to our customers? What value do our customers get out of this? So we predict and prevent about 86% of the cases we deal with in support are detected by us first and automatically result by sending a solution to that customer either before the issue has happened or immediately upon it happening with a solution on how to make sure it doesn't happen again for them. In the predictive case, it's a solution that makes sure they don't hit that issue.
How do you send that to the customers? Is it back via the app or an email notification? Or?
Typically an email notification that's referencing a case that has either what we call KCS, or a knowledge-centric support solution in it, or a full KB article, which is more of a document. But in a lot of cases, it'll be very specific. Like if we understand that you're missing some IP mis-setup on some MPIO path, we will tell them, hey, this IP address is wrong, it needs to be this, if we can tell that, and so on. So it's not just canned information. It's very specific where we can do it for that customer. Okay? So again, that global visibility, it really eliminates that problem from these guys that just can't grok all this information on premise, and they certainly don't know what's happening at somebody else with a similar environment like we do. So we can add a lot of value from that global visibility and learning. In fact, it's a big factor that drives our availability. Again, if we know of an issue that could cause a data services impact in one customer, we're doing everything we possibly can to make sure that happens to nobody else. And that's a huge factor in driving availability when you're talking about preventing something like that from happening across tens of thousands of arrays in the world. Okay? And the net effect of all this, again, a huge value back to the customer. And this is exactly what we started out doing when I joined Nimble. And I joined there about almost 8 years ago now with the idea of building this for the sole purpose at that time of transforming the support experience. And we have absolutely done that. We have never had or hired a level 1 or level 2 support engineer. It's only level 3 support engineers that work at Nimble. And the reason is the level 1 and level 2 is all done automatically. What comes to us are typically harder problems that we haven't seen before, that we have very skilled people at that level dealing with and feeding that information back into the system so that when we learn from that, we prevent it the next time. Okay? So I'm going to step through these fairly quick because we're going to see a bit more of a demo. But I'm just going to illustrate a couple of things. I mean, InfoSight is many things. It's collecting data. It's analyzing it, applying machine learning through a team of data scientists that work with me. And it's a portal where our customers can get a full transparent view of everything going on in their environment from a performance perspective, capacity, all the projections we're doing, all the recommendations we're making to make their environment better, so on and so forth is in that portal. And then it's obviously all the back-end stuff we're doing to learn how the product's behaving and how to make it better. So that's a swath of what Infosite does. I'm going to show you a couple of things in the just in the portal, just to give you a flavor. So that's a latency graph. If you looked at that, you were an admin, and that's all you saw, you'd probably think that was a big problem. That latency spike there. Probably a lot worse problem than that little one. Turns out that what we're trying to do is understand what was the impact of that latency on your workloads. And it turns out we actually take that and we create this impact score, and it turns out that this tinier latency had a much bigger impact on your business. We figure that out, and we do that by comparing and understanding similar workloads across the install base, comparing that against things like escalations, performance escalations, machine learning on that performance profile to understand what things are impacting customers most. It turns out that this guy was actually a backup going on. So it was that kind of a workload that we could figure out. And that really doesn't impact your transactional SQL database. It wasn't impacting that at all. It didn't have a lot of impact on your business, where this one was. So this was actually affecting a transactional database, and we can see that. So we're going to alert more on that and tend to direct you to figuring out why are we getting this latency.
Just to ask a customer question, why wouldn't I just use VROps from VMware to do the same thing?
If it does that, so I don't think it learns across the entire install base to understand how to compare your workloads to tens of thousands of others and be able to zero in on this.
VROps would have given you the first.
Would have probably given you that.
But we're interpreting that.
Okay.
And we do have a lot of customers that have spent time on VROps that are now turning their focus on this.
Okay.
All right, and so as I said, we correlate data across that stack. We collect data across the stack. We're trying to correlate and understand what's happening at each element across that data path. We can do things, and you see this in the Infosite portal. For example, we can pinpoint noisy neighbors in the virtual environment. So we can also say that if you're seeing latency on volume X, it's being caused by volume Y, who is consuming most of the resources at that instant in time. These are the sorts of things that are all available within the Infosite portal. And here's a sort of I took out the other slide, sorry. So the next thing here is that we do a lot of within the Infosite portal is planning and projections around both capacity planning and performance planning for staying, as you're adding workloads, maybe you need to add more CPU capacity to scale with that workload. That's how we scale, by adding CPU, so that's a controller non-disruptive upgrade for us. But again, the other interesting thing, here is this where we're doing some sizing. And so this is where we can, on a pre-sales engagement, we can actually do sizing for what's the right array for you to buy, again, based on the install base that we've seen. So as an example, let's say on a hybrid array, because there's an interesting case there. So let's say you wanted to buy a hybrid array, and you've got 5 SQL databases and an Oracle database and a bunch of VDI. We actually, all you have to do is tell us that you're going to use SQL databases of size X, 10 terabytes each. We know the working set sizes of those databases based on the install base. So a 10 terabyte SQL database has a certain working set size and a certain periodicity, typically, of the workloads that are going on in that SQL database. We calculate all that, and we can determine how much cache in a hybrid array you need to make sure that if you have a periodic workload on a Monday, that data will still be in cache next Monday. So you're getting the optimum performance. And we gain all of that information by looking at the entire install base, and that's what goes into the guidelines under the hood for our sizing tools. This isn't made up by somebody thinking, it'd be nice that if you wanted a 10 terabyte database, we'll sell them a CS 400 or something array. It's all computed based on all of the learnings and the workload profiles across the install base and at what you're specifying your workloads are by application. You don't even need to tell us IOPS. You can, but you don't have to. We'll figure all that out.
So a question on that, on all this data that's required to do fancy statistics. So this is statistics, and yes, it's complicated and so on, but it depends on having a lot of data.
That's right.
That you're collecting from customers. They must trust you an awful lot.
Absolutely.
Because I'm looking at this and just going, cool, if I was able to break into this in somehow and be able to look at, oh, that prediction over there is affecting that customer, awesome, sell.
We sell. These generate leads for us.
No, I mean,
Automatic.
yeah, I can
their
front run the
stock.
market and make money on it. How do you manage that? Like, how do you actually get people to convince?
So we have a
say,
security.
Yes, here, give me all your.
So we're in the cloud. Everybody's, I would have told a sort of a history of why we did this when we did it, but part of it at the time when we invented this was that cloud was becoming, starting to become more and more accepted. It certainly is much more accepted nowadays than even 8 years ago when we started this idea. But there's a lot more acceptance of cloud. There's certainly a lot more security concern. There's certainly a lot more security things we can do ourselves to help alleviate that concern. And so we have security policies, the stuff that is sent is encrypted on the wire, so on and so forth. The data center is certified in that manner. So it's like anything going up into the cloud. Like people are putting a lot more sensitive data than that up in Amazon, for example. A lot more. I mean, this is just operational data. It's never data from a customer perspective. It's just our
It
information.
could still be sensitive, and
It could be, but not credit cards, for example, is what I mean by that, for personal information.
I can get a new credit card. That's easy. But I can't. No, I can't. Once information about my quarterly numbers or I don't know.
No, that's what I'm saying. It's never customer data. It's operational data.
Metadata.
It's
Right. So
for IOPS today. That's the sort of the information.
This InfoSight predicts that the SAN will crash tomorrow,
Yes.
and it will take out my entire organisation, from which it will take me several days to recover.
Yes.
That would move the market, and I could take action on that and do something. But by its very nature, the data that's being shared with you, you have to be able to see it all. So it's not like other kinds of data where each customer can maintain their own keys and make sure that it's only I get to see it.
That's right.
Because then your analytics wouldn't work.
That's right.
So that requires people to trust you a great deal with
Right.
that. With that side of things. So as you're going across from where you are now with Nimble across into the rest of HPE and to enterprises who can be quite paranoid about this, how do you go through that? Hey, yes, you can totally trust us.
Yeah. So I think it's several things. I mean, as I said, we take the security precautions that we think people trust. Customers do trust us. Today, we have 91% of all arrays in the world send us this information. We have lots of objections that when we talk about our security policy and give them that and tell them how we handle the data, what we use it for, and what it is, and that it's opt-in, and it's all described in that manner, 9.1 times out of 10, people opt in to do it, mainly because they understand the value. And they understand there really isn't a lot of risk to sort of more sensitive data that would be stored on the volumes that we're reporting on. So, and I will tell you, we have earned a ton of trust with our customers. There's other things we do from a support perspective where we have the ability to have the array establish a secure VPN tunnel from the array outbound to us that we can then log back into our diagnostics mechanisms to make changes and fix things. Customers allow us to do that all the time. The standard way would be WebEx. We use that too. But I'll tell you, at any instant in time, we're probably working on 100 arrays through that mechanism, where we tell them they need to go do this. They say, hey, we've enabled the tunnel for the next hour. Go do it. And so we do it. So there is a lot of trust that's built up. Basic philosophy, I mean, we collect all this data. We do a lot of data science around that, machine learning, putting a lot of predictive analytics in place and case automation. Our philosophy around this, and again, it's entirely all the way up the stack, so we can actually prevent problems. We've had things where we're doing case automation around VMware issues that they have that we're detecting, even UCS and so on and so forth. Our philosophy here is that if we know of an issue, we're doing everything we possibly can to make sure that doesn't happen to anybody else. One of the mechanisms we use for that are what we call blacklist. So on the Nimble array, when you're going to go do a software update, you do that using the Nimble array GUI on premise. The list of software updates that you're allowed to update to that you see on the Nimble array GUI is controlled entirely from our back end through the cloud. So if, for example, we know that you're going to be susceptible to an issue because of a performance workload and a certain configuration and a certain version of ESX running, and you're going to update to the release of ours that exposes an issue on VMware, we won't let you upload to that release or update to that release. You'll be able to update to the release that has a fix for that. And so that's how we prevent a lot of performance issues and data disruptions. So I'm not going to go over all of this particular one. I'll suffice it to say that before InfoSight, most case automation and support in general was kind of break fix in nature. Something broke, you called people, you went through that horrible cycle, that got worked. We're now at predict and prevent. It's entirely our philosophy from day zero at Nimble. And where are we heading? Self-managing. So when we make these recommendations that you should change this QoS policy on these 2 volumes to increase, to better perform for a particular workload during your peak season at Christmas time, we'll make the change if you permit us. It's like that self-driving car. There's all those recommendations that are being made by that learning that's been done by collecting all of that car data in the cloud and the engineers that are providing those algorithms. But ultimately, they're making solid recommendations, and they're driving actuators, like the brake pedal, the accelerators, the steering mechanisms. Those are our actuators that we will be driving from InfoSight to make those changes and make your infrastructure self-managing.
And I presume in the future there's an obvious synergy with having this available for at least SimpliVity and potentially FreePower and any kind of
Absolutely.
information.
Yeah. So this InfoSight was one of the big reasons why HPE acquired Nimble. It was obviously the product line and the fit there, but also the thing that tipped them over was the support model we have in InfoSight. And so yes, we have every intention of extending this to other product lines.
So how do you maintain that support model of doing so well in a much bigger company, HPE, which maybe doesn't have...
To be honest with, I'll tell you right now that when we went through due diligence, we did about a 12-hour session with about 80 people from HPE explaining in absolute excruciating detail our entire support model and every technical detail about InfoSight. And at the end of that meeting, the primes from HPE basically said, we have to spread this magic and don't screw it up. And so the first point about not screwing it up is that our support organization, the one that reports to me, does not report into global corporate support at HPE. We've kept it in the business line in order to not disrupt anything, and we're working with other business lines within other product lines within storage to adopt some of those processes that we have under the hood of InfoSight to really feed the predictive analytics and so on that we do. And we're working on those product lines to add InfoSight to that.
So your support is also being used to reinvent HPE other storage products to get...
They're very interested in learning from how we do this and seeing where there's the fit and how we can influence things. Absolutely. Yep. It's an amazing model. I mean, we have no, as I said, no level 1, no level 2. Our average hold time on the phone is less than 1 minute. Our average case resolution effort is less than 45 minutes. Start to finish.